Class 10 Cbse Science Chapter Light, Reflection and Refraction. In this module we will discuss points 9 to 11, that is refraction of light, refraction through a rectangular glass slab and the refractive index. Refraction of light. Light seems to travel along straight line paths in a transparent medium, isn't it? Yeah. What happens when light enters from one transparent medium to another? Does it still move along a straight line path or change its direction? Let us look at some of the common observations which you might have experienced in your day-to-day life. The bottom of a tank or a pond containing water appears to be raised. Another situation is when a thick glass slab is placed over some printed matter, the letters appear raised when viewed through the glass slab. Why does it happen? Have you seen a pencil partly immersed in water in a glass tumbler? It appears to be displaced at the interface of air and water. A lemon kept in water in a glass tumbler appears to be bigger than its actual size when viewed from the sides. How can you account for such experiences? These observations indicate that light does not travel in the same direction in all media. It appears that when traveling obliquely from one medium to another, the direction of propagation of light in the second medium changes. This phenomenon is known as refraction of light. Now, how do we define refraction? When light rays traveling in one medium are incident on a transparent surface of a medium, then they get deviated from their original path. This phenomenon of bending of light when it passes from one medium to another is called refraction of light. Refraction of light from a plain transparent surface. As you see in the picture, xy, x dash, y dash represents the second medium, which can be a rectangular glass slab. And this picture shows you PQ is the incident ray of light which is traveling from the first medium air, and then it gets refracted into the second medium, which is glass, at an angle of refraction R. So the light ray PQ bends once it enters the second medium. Refraction through a rectangular glass slab. The second picture here shows points E, F, G and H. This is an activity which can be done with a drawing pins and a board, where you can keep a piece of white paper, A4 paper and a glass slab over that. Mark the outline of the glass slab and then do this activity to trace the image of the first placed two pins E and F from the other side of the glass slab. So once you should place them in such a way that these appear in a single line. When you look at these pins, they should appear to be in the same line and they should be one behind the other. So when you try to fix them in this way, it's an activity which can be done in the school laboratories, children. When you try to fix them in this way and then remove the glass slab and then join the dots, you can visualize the phenomenon of refraction. Once you join these dots E, F, G, H and then O, O dash, you understand that the incident light ray is entering the medium of glass, and during this process it bends. Its path is getting deviated from the expected path which is shown in dotted lines. Now, laws of refraction of light. The following are the laws of refraction of light. First law, the incident ray, the refracted ray and the normal to the interface of two transparent media at the point of incidence all lie in the same plane. Second law, the ratio of sine of angle of incidence to the sine of angle of refraction is a constant for the light of a given color and for the given pair of media. This law is also known as Snell's law of refraction. This is true for angles I between 0 and 90 degrees. So if I is the angle of incidence and R is the angle of refraction, then sin I by sin R equals constant. For normal incidence, I is equal to 0, that is sin I equals 0. Therefore, sin R equals sin I by n equals 0. That is, R equals 0. The ray is refracted without bending. When the light is incident normally onto the second medium, then angle of incidence would be 0, and therefore from this equation we find that the angle of refraction also is 0, which means the light travels along the normal through the second medium without bending. Now let us consider the term refractive index. A ray of light that travels obliquely from one transparent medium into another will change its direction in the second medium. The extent of the change in direction that takes place in a given pair of media may be expressed in terms of the refractive index. Refractive index of a medium gives an indication of the ability of that medium for bending the light. It can be defined as the ratio of the speed of light in vacuum to the speed of light in that medium. Consider a ray of light traveling from medium 1 into medium 2 as shown in figure. Let V1 be the speed of light in the first medium and V2 be the speed of light in second medium. The refractive index of medium 2 with respect to medium 1 is given by the ratio of speed of light in medium 1 and speed of light in medium 2. This is usually represented by the symbol N21. N21. This can be expressed in an equation form as refractive index of medium 2 with respect to medium 1, N21 equals speed of light in medium 1 divided by speed of light in medium 2, which is equal to V1 by V2. By the same argument, the refractive index of medium 1 with respect to the medium 2 is represented as N12. It is given by the relation N12 equals speed of light in medium 2 by speed of light in medium 1, that is V2 by V1. If medium 1 is vacuum or air, then refractive index of medium 2 is considered with respect to vacuum. This is called the absolute refractive index of the medium. It is simply represented as N2. If C is the speed of light in air and V is the speed of light in the medium, then the refractive index of the medium Nm is given by Nm equals speed of light in air by speed of light in medium, which equals C upon V. The absolute refractive index of a medium is simply called its refractive index. That's a point to note. The absolute refractive index of a medium is simply called its refractive index. The ability of a medium to refract light is also expressed in terms of its optical density. In comparing two media, the one with the larger refractive index is optically denser medium than the other. The other medium of lower refractive index is optically rarer. The speed of light is higher in a rarer medium than a denser medium. Thus, a ray of light traveling from a rarer medium to a denser medium slows down and bends towards the normal. When it travels from a denser medium to a rarer medium, it speeds up and bends away from the normal. Optically denser and optically rarer media. When a ray of light is incident from one transparent medium to another transparent medium, it bends from its original path in the other medium. Angle of refraction R is different from angle of incidence. From Snell's law, sin I by sin R equals n, which is a constant. So first case, if the refracted ray bends towards the normal, then angle of refraction R would be less than I, and then n equals sin I by sin R is more than 1. The other medium or the second medium is called optically denser than the first medium. Alternately, a medium in which the speed of light is less is called optically denser medium. Second case, if the refracted ray bends away from the normal, then as in the picture, the angle of refraction would be greater than I. So n equals sin I by sin R would be less than 1. The other medium or the second medium is called optically rarer than the first medium. Alternately, a medium in which speed of light is more is called optically rarer medium. When a ray of light goes from an optically rarer medium to an optically denser medium, then the speed of light decreases and a ray of light bends towards the normal as in figure 1 here. In such a case, the angle of refraction is smaller than the angle of incidence. This is clear in the first picture. Now, second case, when a ray of light goes from an optically denser medium to an optically rarer medium, then the speed of light increases and the ray of light bends away from the normal as in the second picture. In such a case, the angle of refraction is more than angle of incidence.